Course 3, Lesson 82 is all about graphing linear equations using intercepts. So we are looking at equations in standard form, solving them for the intercepts, and graphing them on a coordinate grid. By doing this, we just have 2 points that help us draw our line. The other part of our lesson today is needing to solve a system of linear equations. That's just really saying we have 2 lines, we need to graph them, and the solution is the intersection. So we'll talk about this in a little bit. First, though, we need to look at our standard form. Now, we've talked about a different form of linear equations before, and that is slope-intercept. Slope-intercept, let's see if I can get this to draw. There we go. Slope-intercept form is saying that we have y equals mx plus b, where we have the slope as m and the y-intercept as b. And we can put those on a coordinate grid and graph it pretty quickly. But unfortunately, we don't have all of our lines in that form. Some of them are in this form. ax plus by equals c. So if we look at these two equations, 3x plus 2y equals 9, and x equals 9 plus 2y, we can see that this one over here is actually in standard form because x and y are on the same side. Typically, we get them on this left side and put everything else on the right side. As we can see, this one unfortunately is not in standard form. So in order to get it there, we would need to move this 2y to the other side by subtraction. Minus 2y minus 2y. And that would give us an answer to say that we have a standard form of x minus 2y is equal to 9. Okay, so we can do that. We can move around our variables to make sure that we have our x and our y variables on the left side, our numbers on the right. Same with this one, except I'm going to do a couple steps. First, I'm going to subtract y to get it on the left side. So we have everything on the left side, 4 plus 5x minus y equals 0. But we can't leave that 4 on the same side as those variables. So we are going to have to subtract it. Subtract 4, subtract 4. So our equation is 5x minus y is equal to negative 4. We do this so that it makes it a whole lot easier to find the x-intercept and the y-intercept. Our x-intercepts and y-intercepts, remember, is if we have a coordinate grid, and let's say we have an equation, a line that goes like this. Well, we would say that wherever it crosses the y-axis, okay, this is our y-axis, x-axis, wherever it crosses our y-axis, we call that the y-intercept. Wherever it crosses the x-axis, that is our x-intercept. Okay? Both of those are necessary when we talk about our standard form. Let's see how we get those exactly. So let's go to this one. 2x plus 3y equals 12. Well, we can see that it's already in our standard form, which is good. And now we just need to solve it. So we start off with looking at a table, an xy table. We want to know when x is 0, what is y? And with another question, we have what if y is 0, what is x? What this is telling me is that if x is 0, that means that I am not going to move on my coordinate grid left or right any, because my x is 0. I'm just going to go up or down. That means that when I plug in x as 0, I am finding my y-intercept. Okay, this one is going to give me my y-intercept. Similarly, if y is 0, that means that I'm not going to go up or down any. I'm just going to go side to side. If we put in y as 0 and find x, that means we are finding my x-intercept. We do this in 2 steps. So we have our equation. 2x plus 3y is equal to 12. So we write it down. 2x plus 3y is equal to 12. Well, first we need to see if x is 0. All right, so we plug in x as 0. Keep everything else the same. We will figure out what y is. So that's what we need to do. Well, if x is 0, that means 2 times 0, that's nothing. That actually gets rid of that term, and all we're left is 3y equals 12. Well, to solve that, 3y is equal to 12, we need to divide by 3. So y is equal to 4. So what this is telling me is that if x is 0, so I'm not moving side to side, let me erase some of these silly lines. If we are not moving side to side, we have found my y-intercept. So I put 0, 4. That is my first plot. So I go up 4 and put a dot on my coordinate grid. Well, the same thing is going to happen, but instead of putting x as 0, we're going to put in y is 0. So let's do that. We put down our original equation, 2x plus 3y is equal to 12. And we put y as 0. So we keep the 2x this time, but replace y with 0. Okay, now this one goes away because 3 times 0 is just 0. And I am left with 2x equals 12. So we divide by 2, and we say that x is equal to 6. So we can fill in the rest of our table and say, well, now that y is 0, I'm not going up and down, I'm just going to go across. I'm going to go across 6. We have our 2 intercepts, and now we can make our line. Okay? And that is going to be the graph of this equation. Okay? Let's try another one really quick. I'm just going to go through the steps pretty quickly. Okay? Let's try this one. You know, I'm going to start with this one actually. 2x plus y is equal to 8. All right, so I plug in x as 0. So 2 times 0 plus y is equal to 8, which means this goes away, and we are just left that y is equal to 8. All right, which means x, I'm not going across at all. I'm just going to go up 8 and be right here. Next, I'm going to plug in y as 0. So we leave 2x, but now y is 0. And that's going to equal 8. So this goes away, and I divide by 2 on each side, so x is 4. Sorry about that. X is 4. All right, so instead of going up at all, I go across 4. And now I have my line. It's as simple as that. Plugging in x is 0, figuring out what y is. Plugging in y is 0, figuring out what x is. And that is how we can graph it in standard form. Sometimes, though, we are given a word problem, something like this. Martin is thinking of 2 numbers. The sum of the numbers is 3. If you double the first and add the second, the sum is 8. Write 2 equations to find the numbers, then find the intercepts and graph the equations. So what this is saying is that I need to come up with 2 different equations to talk about the 2 different parts. The first one is the sum of the numbers is 3. Since we don't know what either of the numbers are, and we need to assume that they're different, we can say, well, the first one we're going to call x, and the second one we're going to call y. And in this part it says the sum, so we need to add them together. The sum of those 2 numbers is 3. We have our first equation. Then we look at the second part. If you double the first and add the second, the sum is 8. Well, we said x was my first, so I'm going to double it. We can show that with 2x. And we're just going to add the second. We don't do anything with that y. We don't multiply it by anything. We just say we're going to add the second. That sum is going to equal 8. Now, when we see these 2 equations, we can see, well, these look like they're in standard form. And that's true. They are. we can graph both of these on the same set of axes and figure out what the solution is to this riddle. Now you could sit down and say, all right, maybe the answer is 2 and 1, but it doesn't work all the time. Maybe 0 and 3, maybe -1 and 4. Okay, we could sit here and try and riddle it out, but we have another way. We can graph them. And wherever these two lines intersect, that is our solution. So let's try it out. Let's first work with x plus y is equal to 3. Well, we make our table, x, y. We have 0 for x, 0 for y, and let's fill in the other parts. So if we say x is 0, so 0 plus y is equal to 3. Well, that means just that y is equal to 3. Let's do it again now with y equals 0. So x plus 0 is equal to 3. Well, that just means that x is equal to 3. Okay. Now we need to do it with the other one. We take our other equation and we make a table as well. But actually, before I move on, let's just graph this equation. X plus y is equal to 3. So we need to go 0, 3. 0 for x, up 3 for y. And then 3 comma 0. We need to go over 3 and up nothing for y. So this is our first line. Okay. Next, we have 2x plus y is equal to 8. So we have my x, y, we have my 0 and my 0, and let's fill in the gaps. Okay, well first we need to say, all right, if x is 0, what is y? Well, that means that we have 2 times 0 plus y is equal to 8. So we say y is 8. Then we say 2x plus 0 is equal to 8. And really, we just need to divide by 2. So x is equal to 4. So when we go to graph this, we would say, all right, 0 comma 8, that's my coordinate point. So 0 on the x, but I'm going to go up 8 for my y. It should be up 8. And then we go over 4 for my x and up 0 for y. That's my x-intercept. And we draw my line. All right, let's see where these intersect. Now, my lines are not perfect, okay, so we're going to have to see what we can do here. And let's see, they cross at about here. Well, that would mean that we have an answer of 5 comma negative 2. That's the intersection point, 5 comma negative 2. Let's see if that works in our equations. Let's plug it in both of them. So first, we're going to plug it in up here. If we do x as 5 and y as negative 2, does that give me 3? Yes, it does. And let's plug it in the other one. 2 times 5 plus a negative 2. Well, that's just 10 plus negative 2, which gives me 8. So it works for the first one, and it works for the second one, meaning that that is the answer to my riddle. 5 is the first number, negative 2 is the second number. We can go about any set of systems of equations like this, graph them, and see where they intersect. Okay? Be precise with this. All right? I wasn't super precise because on this big board, it's hard to draw straight lines, but you have resources to help you. So make sure that you draw really straight lines so that you can see exactly where they intersect. So in this lesson, we figured out what is standard form, how to graph it, and also how to graph the system of equations to be able to solve a riddle like this. I hope this is helpful for your homework and for studying.